If you've donated blood before, you were probably told what blood type you have: A, B, AB, or O. But why is this important? Your blood can't be given to another person without first identifying the type, because red blood cells have different antigens based on blood type. Antigens are structures that cause an immune response in the body. This means that if you donate blood to someone whose blood has different antigens than yours, his or her immune system will produce antibodies aimed at destroying the donated blood. A person with blood type A has red blood cells with A antigens, while a person with blood type B has red blood cells with B antigens. Someone with the AB blood type has both A and B antigens, while someone with O blood type has no antigens. This is why a person who has an O blood type is called a universal donor. The lack of antigens means that people with blood types A, B, and AB can receive O blood without having an immune response. So what determines blood type? Blood type is inherited based on the transfer of alleles from parents to offspring. Alleles are different forms of genes, which are pieces of DNA that carry genetic information. Blood type alleles are formally depicted with the letter I, or I, but can be simplified by using the blood type letter. Blood type inheritance is more complicated than typical Mendelian inheritance, where there are only two alleles, one dominant and one recessive. Dominant alleles mask recessive alleles when a person receives both. Of the three possible blood type alleles, A, B, and O, each person receives two, one from each parent, which determines their blood type. These two alleles together are the genotype, or genetic makeup. This genotype determines the blood type, which is a phenotype, or physical characteristic. A person with type A blood can have two possible genotypes, AA or AO. A person with B blood type also can have two genotypes, BB or BO. The A and B alleles are dominant over the O allele, which means the O allele is recessive and will be masked. A person with O blood type can only have one genotype, OO. This person must have both recessive O alleles to show the O phenotype. Likewise, a person with AB blood type can only have one genotype, AB. This phenotype displays codominance, a phenomenon in genetics where neither allele is dominant and the individual displays both phenotypes. Neither allele, A nor B, is dominant over the other, and a person with AB blood type has both the A and B antigens, meaning he or she shows both phenotypes. Punnett squares are charts that can help determine the probability that offspring will have certain genotypes or phenotypes. As an example, let's say one parent has an AB blood type and the other parent has an O blood type. As shown in the image, two different genotypes can result from this mix, AO and BO. Each of these genotypes has a 50% chance of occurring in an offspring, since each occurs in two of the four boxes of the Punnett square. The AO genotype will yield an A blood type as the phenotype, while the BO genotype will have a B blood type for the phenotype. This means there's a 50% chance of the offspring having the A blood type and a 50% chance of the offspring having the B blood type. When using a Punnett square with A and B blood type parents, the genotypes of the parents must be known since each has two options for genotypes. Sometimes it's possible to work backwards and figure out the genotypes of parents if the genotype of the offspring is known. For example, we already learned that a person with the O blood type must have the genotype OO. So let's say one of the parents of an OO blood type child has the A blood type, and the other has the B blood type. The genotypes of the parents must be AO and BO, because they each had to give the child one O allele. humans can have 4 different blood types: A, B, AB, or O, which are determined by 3 different alleles, simplified as A, B, and O. The A and B alleles are dominant over the O allele, but neither A nor B is dominant over the other. This means that a person with an AB genotype will show both the A and B phenotypes, where his or her blood cells will have both A and B antigens.